Hi, my name is Mohammed Aslam. In this lecture, I will be implementing GPIO via MIO in Zinc 7000 SoC. This lecture is the continuity of the previous lecture. In the previous lecture, we had a theoretical knowledge of MIO, GPIO, and EMIO. Okay, in this lecture, I will be using Vivaro as a software and ZedBoard as a hardware. Great. As we already know that GPIO are available for each MIO pin, and pin 0 to 31 are available on bank 0 and 32 to 53 are available on bank 1. Again, this block diagram is taken from the previous lecture. This block diagram is taken from the ZedBoard manual. Thanks to ZedBoard manual, which makes my life easier and of course yours as well. If you see here, there are three basic or main blocks in block diagram. One is PS, processor, PL, FPGA, and MIO. In this part, we will not be using FPGA, so we will not use that part, and I will not explain anything about it. From the previous lecture, we already know that PS can monitor or control external signal via MIO, and as we can see from the block diagram, there are different peripherals which are connected to the MIO, and that MIO is connected to the PS. So therefore PS can communicate with these peripherals via MIO, and by that way it can make a communication link with the external world. The main focus of this lecture is to make you understand how we can use MIO to monitor or control the external signal on PS side. In this lecture, I will use only two peripherals. One is LEDs and buttons, and other one is Pmod. They are built-in hardwired two buttons and one LED in ZedBoard and one Pmod in ZedBoard. As we can see here, it is user select. It means you can see any signal on these pins. Since it is 8-bit, so you can simultaneously monitor or control 8 external signals. That signals can come from anything. It can be motor, it can be controller, and it totally depends on your application. For example, in this lecture, I have used logic analyzer. Logic analyzer is connected with this Pmod, and these Pmod's signals are read by this logic analyzer, and that signals can be observed on my PC. And I will show you in a short while. Beside that, we have two buttons that I have shown you before and one LED, and we will be using them as well. This block diagram is again taken from the previous lecture, but I realize it is important to repeat because I will be using some drivers which has a direct link with this block diagram. So this block diagram has 4 different register data read-only, that is used to read data from the external world, from the pins, and that is data is used to write something on external pins, and this is direction to set a direction. So it means if you can set it as an input or as an output. Output enable is a fourth one. This is an output enable, and this is of course it is used to enable or disable output. So these are the 4 corresponding drivers which are provided by Xilinx to us, which of course facilitate our life. And we will be using these 4 drivers in the following video, or in the following part of the video. I will be using these drivers because there is no need to rediscover the America. So if you want to rediscover the America, please write. Yes, okay. Uh, let's start. Let's go to the Vivaro and start the real-time implementation. This is Vivaro. I am using Vivaro 2016.2. You can use any Vivaro. It's totally up to you. I'm using. Uh, I have selected ZedBoard from the boards icon. You can select like that and click next and then finish. Of course, it will create and initialize, and it will do some initialization. You don't need to do anything. You just need to wait. Then click on the create block design. You can write anything here. It's totally up to you. I will leave it like that. Great. Now from here you can find zinc PS. As I mentioned a few minutes before, I will be using only PS processor. So you can see here Zinc 7000 PS processor. The next step is just run block automation and click OK. And just wait. Let's see what will happen. There are many signals which are appear here, but the things which is more important for us is fixed IO. If I just expand this fixed IO, you can see MIO 0253. These MIO we will be using. So all the other signals we will just deselect them because these signals are connected to the PL. Because we are not using PL in this lecture, so I will just disconnect them. Just double click on PS system 0. It will just pop up. The first thing is to PS and PL connection. Just deselect some signals because these signals are connected to the PL. Next thing is master AXI interface. That AXI interface, we don't need to use that because again we are not using PL. We also need to disable the clock, which is again going to PL. Some peripherals. TTC timer, USB 0. Okay. Now you can see we have just two signals here. DDR-RAM, that is a memory, so we will use that memory later on. So I will give a complete lecture on DDR-RAM, so don't worry about it. The next step is to validate design. So there are no errors or critical warning in this design. Okay. Try to follow the steps because following the steps make our life easier. And it's always a good practice to follow the steps. And I always do like that. Generate output product. Click generate and wait for some time because it's generating, something is being run in the background. It is just copying some files from Xilinx IPs to the local repository. Every time you generate anything, you need to follow these steps. Yeah, we need to wait. Okay, generation of the output products completed successfully. Okay, the last step is create HDL wrapper and let Vivaro manage wrapper and auto update. Okay, go on and file export hardware. We will not include bitstream because we are not using PL here. Finally, launch SDK. It will just export some drivers from Vivaro to SDK, and it's now launching. Importing hardware specification that I have mentioned you. It will just import some drivers which are required to configure, to monitor, to control the external peripherals which are connected to the PS. Yeah, this is HDF. This is most important file, hardware defined file. So these are the peripherals which are connected to the to the PS, and these are the addresses. The thing which we are looking for is GPIO. Where is GPIO? Yeah. Where it is actually? Should be somewhere here. GPIO. Yes, it is here. GPIO. So the processor can access GPIO on this address. The next step is create application project. You can write any name that you want. I will write GPIO GPIO MIO test. Click next. Hello world. Finish. Great. Now if you scroll down system.mss, so there are different drivers present. So you can see peripheral drivers here. So there are different drivers. We are just looking for GPIOs. So GPIOs, there are different example provided by Xilinx. You can use these example. These are the example. You can use this example directly. I have written my own code, so I will use my own code. So because I want to make you understand how the things are working. So this is a hello world. I will just copy my code and paste it here because it is a tested code. So don't worry, I will provide all these code to you so you can compile and rerun all these code on your side if you are interested, of course. So just few minutes before I have shown you 4 different drivers functions. So this is set direction, that is DIRM. So I have just explained there are 2 buttons and 1 LED. The button is connected to 50 and 51 MIO. Remember, we have from 0 to 53 MIO connected via GPIO. Okay, so GPIO can be connected to MIO from 0 to 53. So ZedBoard has hardwired connection to the buttons, and these MIOs are 50 and 51. And you can find these numbers from ZedBoard manual, and I have taken from them. That's all. So 51, and I have used just one button, 50, that and I have put 0 here. So I am using them as an input, and that is natural and that's good. I mean that is natural because button can be used as an input. So I just set their direction as a 0. I mean 0 mean input, 1 mean output. So set direction and set output, and these are the 2 registers, and these are the LEDs. So and in LEDs this is a seventh MIO is connected to the LED. Again, this value is taken from the manual. You can see that value in the ZedBoard manual. Great. So this is set direction. This is this is set output. So I have set direction and output as a 1 because I want to write some data on LED. And again, it's natural because LED can just receive a data. It cannot provide anything to the processor. The next thing is Pmod. Pmod has 8 pins, so I have configured all the 8 pins as output. It means I can write data on these 8 pins. You can configure as you want. It's totally up to you, and it's totally up to your application. I just want to make you know how to use them. If you have any question, you can write in the comment box. I will try to answer your questions. Again, so 0 so 0, 9, 10, 11, 12, 13, 14 and 15. These are the MIO numbers which are connected to the Pmod, and these values are again taken from the ZedBoard manual, and I have put 1 1 1 1 1. It means they are configured as an output. Okay, so the configuration is done. Now I want to read and write data. Now I have a while one here. In while one, what I'm doing here, I'm just reading a 50. Remember, 50 is a button. So I'm reading the value from the 50 input and writing back that value to 7. 7 means LED. So whenever I press a button, the LED should blink and it should glow up after 100 microsecond. And of course, it's not perceivable, so as soon as you press a button, the LED should glow or it should blink. The next is Pmod E. Pmod, so at the first step I have written 1 to first 4 Pmods and 0 to the rest of the Pmods. After 100 microsecond, I have just reversed the values. The first 4 become 0 and the last 4 become 1. It means after each 100 microsecond, they will toggle, they will alternate the values, and we will see the results. So the first part, since it is a while loop, while 1, so it will continue. So then now I will run the system. I have already connected ZedBoard on my side, and I suppose you also know how to connect ZedBoard with your PC. Now I run the system. I'm just waiting. So okay, so let me do it again. JTAG cable is disconnected. Let me connect the cable. Sorry for that. My cable was disconnected somehow. Again, I will run. Great. Now it's connected. So the first part, I have a short video because I can't observe on my PC. So I have just taken a small video. I will show. As soon as I press the button, the LED will glow and it will just blink. Yes. This is a small video here. If I turn on the video, this is a 50 and this is 51. As soon as I press 50, you can observe the LED is blinking. That's great. That's great how the system is working. Nice. For the second part, as I have a logic analyzer software on my PC, I can show you the real-time outputs here. As the system is running now, it is in the while loop. I have a duty cycle of 50%, and the first 4 signals should be just reverse of the last 4 signal. Okay, so this is a logic analyzer. If I press on start, I have pressed. It is taking some time again. Yes, great. If I stop it, great. You can see here. So the first four signals are showing 1 1 1 and the last four signal showing 0 0 0 0. In next 100 microsecond they become 0 0 0 0 and the last become 1 1 1 1. That's great. The system is working. It means nice. So that's all for today. If you have any question or any query about it, just please write in the comment box. Next thing is I will also provide the code so you can compile on your side. You can find the link which are given below. And lastly, don't forget to subscribe and share my channel.